Welcome to Creating a Control Chart in Excel, brought to you by the Systems Thinking Academy. This is the follow-on video from Control Charts 101, where we talked about the what, the why and the how of control charts, and we even created one on screen. But in the spirit of it being a 101 and therefore intended to be bite-size, I didn't share with you the details of how you create a control chart in that most common of applications, Microsoft Excel, and so this video is intended to close that gap. Now, I know that there are professional statistical analysis tools on the market such as Minitab. There are add-ins that you can buy for Excel that do this for you. There are even software packages specifically designed for creating control charts such as these. But in my own personal experience, most normal people just want a simple tool that they can use with simple instructions without having to spend extra money on software licenses, without having to go through IT procurement loops. And once you've done this in Excel a couple of times, it becomes second nature anyway. And even if it doesn't, you can just save your document and use your document as a template for the next time you need to use it. In the 101 video, we used the example of a factory that manufactures widgets and produces a certain number of defective widgets every day. We had a run of data. I'm showing you that data on screen now, so it's 20 days worth of data. Across those 20 days, we've got variation in terms of the number of defects produced on any given day. So all of that was explained in Control Charts 101, and the process for creating the control chart was also explained in 101. So what I'm going to do now is just repeat the explanation of that process, but specifically with creating the control chart using Excel in mind. So follow me on screen as we go step by step through the process of creating the chart now. We start with two columns, the day and then the number of defective widgets for that day. And if you remember back, the first thing we need to do is to calculate the mean average for that set of data. But first, there's a little bit of setup we need to do. Let me explain what this is and why. A control chart contains 4 different series of data. It contains the data set itself, it contains the average, it contains the upper control limit, and it contains the lower control limit. Now, to get these values to display as independent lines on a line chart in Excel, you have to create runs of data for each data point, even when it's things like an average. So it's fine for the actual data itself, where we've got data point 1, which is a value of 5, data point 2, which is a value of 7, and so on. But the average, what we need to do is create 20 data points, all with the same value, so that when we come to plot a chart, it looks like a straight line, and the same applies to the upper and the lower control limits. If that doesn't make sense yet, don't worry, keep watching, as it will make sense as we go through the process. So let's add the average, and what I'm going to do in the spirit of what I've just said is I'm going to create the average for the whole data set and then copy that value all the way down for as many items as we have in our data set here. So first let's make the column header. And now let's calculate the average value using the average function. And let's just stop here a moment, because what we could do using Excel is create our continuous line of data by taking the fill bar from this column D3 and dragging it all the way down to D22 and then letting go. But look what's happened. We've got different values in each row, when actually we know that 7.7 is the true average for all the rows. Now this has happened because Excel's tried to be helpful. What it's done is it's detected that we've copied a formula down from one row to the next and one row to the next and one row to the next, etc. And in doing so, it has modified the cell references in those copied formulas to reflect the fact that they are 1, 2, 3, etc. rows further down. Normally that would be helpful, but in this instance we don't want Excel to behave in that way. So the workaround is that we go to the first row and we modify it so that the formula reads average, but with a $sign in front of the 3 and a $sign in front of the 22. The effect of that is to tell Excel not to try and be clever with those row references. So if we drag the formula down using the fill bar now, we'll see that we get the same value for the average across the entire data set. So we've got 7.7 repeating 20 times, which is exactly what we want, for reasons that will become clear shortly. So now we have the average, let's move on to the moving range. Remember, the moving range is a run of data that expresses the difference between each data point and its subsequent data point. So let's create the column header and then create the formula to calculate the difference between one row and the next row. Having done that, we can then copy the formula all the way down, but this time what we're trying to do is calculate the difference between each row and its subsequent row. And so in this instance, when Excel tries to be clever and tries to update the cell references on the basis that we've moved or copied cells down, we want it to behave in that way. So whilst when creating the formulas for the average value all the way down the data set, for calculating the moving range, we want to just let Excel do its own thing. But remember, back to Control Charts 101, when we talked about the size of the moving range always being one smaller than the size of the data set to which it applies, that means that we only create 19 values for the moving range. Okay, so now let's pause a second and look at the moving range data. What you can see is a column that contains a mixture of positive and negative numbers. And that's because some of the values, like for example, the difference between 5 and 7 is +2. But the difference between 7 and 4 is -3. Now for calculating the moving range, we don't care whether the difference between two numbers is positive or negative. All we care about is the difference between the two numbers. So what we need to do is tell Excel to just express the difference between the two numbers and hide the fact whether it's plus or minus. To do that, we need to wrap the formula in a function that's built into Excel. The function is called ABS, ABS meaning absolute value. And what ABS does is it takes for an argument a number, which could be a positive or a negative number, and it simply returns its positive equivalent. So if I pass it 2, as in for the first item in the moving range, it'll return me 2. But if I pass it -3, as in for the second item in the moving range, it'll return me 3. So if we copy that formula all the way down using the fill bar, we get a moving range looking like this, which is an exact match for the moving range that we had in Control Charts 101 video. Okay, next step, mean moving range. So same process as we used to create the average for the data series. We need to create a column for the mean moving range. And then having done that, we need to use the average function, highlight the data range that contains the moving range, and then just edit that formula again so we've got the $ in front of those row references, because again the mean moving range needs to be the same value for all of the rows. So now we have the mean, the moving range and the mean moving range. The last two columns we need to create are the upper control limit and the lower control limit. I'll create the column headers for both of them together because, as you might remember from Control Charts 101, the formulas for the two limits are almost identical except one is the inverse of another. Okay, so remember the formula for the upper control limit. It's mean plus mean moving range times the scaling factor, which is 2.66. And it's vital that we use brackets around the mean moving range times 2.66. This tells Excel to calculate the results of that expression first before it adds the mean to it. If we didn't use these brackets, Excel would calculate the expression in a different order and we'd end up with the wrong number. So now we've got our formula, we just copy that all the way down. Now you may be asking, do we use the $ to lock those cell references like we did with the averages, or do we just leave it and let Excel do what it needs to do? Well, actually there's a third variation, which is it doesn't actually matter in this case. And the reason it doesn't actually matter is that all of the cells from which the upper and the lower control limits are calculated are fixed. So whether we put $ in front of cell references or we don't, it won't change the results. So let's just leave the formula as it is and copy it all the way down. And our final bit of data crunching is the lower control limit. That's dead simple because it's exactly the same formula as the upper control limit, but we use the minus sign instead of the plus sign. So it's mean minus, open brackets, mean moving range times scaling factor 2.66, close brackets. Copy that all the way down with the fill bar, and there we have all the data that is necessary to generate a chart in Excel. So let's do that now. So first things first, what we need to do is tell Excel that we're going to create a chart, and the first step in doing this is to highlight data that we want to use for our chart. So we'll highlight this whole range of data now, and then we go to the chart menu, and the type of chart that we want to use is a line chart. And just to keep things simple, let's use a 2D line chart. And when we do that, the default behavior of Excel is to give us a chart that looks a little bit like this. So at this point, we're not actually a million miles off the finished product. Most of the work that we need to do from this point on is down to personal preference in terms of the specific colours that you'd like to use for any of the given data series. I personally like to use blue for the data itself. Sometimes it's helpful to add markers to the data to help facilitate conversations about individual data points. I use black for the average. I use red for the upper and the lower control limit. Remember, the moving range data and the mean moving range data only exist to help us calculate the control limits, and they don't appear on the chart at all. So the first thing we need to do is just remove the data that we don't need on the chart. Once we've done that, it's just time to let our creative juices flow and recolor, resize, do whatever we want to do to make the control chart look how we want it to look. So that's how you create a control chart in Excel. I hope this video has been useful. Please leave any comments, feedback or questions in my feed below. Thank you for watching and see you on the next video.